İşte başlıyorum. Dediğimiz gibi bu Geometry Revisited şeyden başlayacağız. Şimdi önce aslında gerekli olan ön bilgiler. Bugün date October 12. Okay. For this, first, let's start with, let's start with this theorem that you might know, but there's a simple proof that we will use this all the time. This is like preliminaries. So I'm planning to cover most of the chapters of sections of this book. And let's start with the preliminaries. And the first theorem that we will prove is that if you take a circle with center O, and when you draw an angle like this, let's call this angle alpha, and let's take a point on the circle, and let's draw this angle beta. And the theorem says this beta is equal to 1/2 alpha. So the precise statement is that the angle subtended by an arc at the center of a circle so the arc is this one at the center of a circle is twice the angle subtended at the point subtended at any point on the circumference on the circle. Okay, now namely this in this picture alpha is equal to 2 times beta. That's what it says. Okay, let's give an easy proof of this statement. Well, I will not start from the axioms of geometry, but I will assume the minimal background. So let's see. So if you draw the circle, let me draw this same thing once again. And I might say, so this is so if you draw this arc, and if you say this angle is X, that angle is Y, so that this is let's say ABC, and O is so these equilateral triangle, so isosceles, isosceles, two sides are the same, so OA is equal to OB, so that the angle X is, and that angle is the same as X, and this angle is Y, and let's say this angle is Z, and that the other angle is T, let's say. So then we have beta is equal to X plus Y, and if you look at this triangle OAB, then 2X plus Z is equal to 180 degrees. Also, if you look at the other triangle AOC, then 2y plus t, y plus this is t, that's equal to 180 degrees. So if you add them up, 2 times x plus y plus z plus t is equal to 360 degrees. So therefore, this is x plus y is bir kişi daha derse nasıl alacağız? İşte geç gelenleri almamak lazım derse. Onu nasıl bulacağım şimdi ben? Şeye geçmem lazım. Geç gelenlerin böyle sıkıntısı var. Şeyi değiştirmem lazım. Neyse. So x plus y is, what was x plus y is beta, right? X plus y is beta, so that 2 beta is equal to 360 degrees minus z plus t, but the angle at this here is 360 degrees, so that 360 minus z plus t is precisely alpha. So that's the proof of this statement. So we will use this all the time, this fact. So namely, so it's a fact that you learn from the high school, that if you take an angle from if you take an arc on the circle and the angle from the origin, the angle alpha, and when you draw this angle beta, then alpha is 2 times beta. Okay, next, this again, we will use this all the time as a corollary of this statement, that angles subtended by the same arc. Oops. Angles subtended by the same arc at the circumference are equal. Namely, when you draw, so let me draw this first proof. So it will follow from the theorem. So when you draw this circle, when you take an arc, let's take this arc like this, and let's take one angle like that and another angle like this, so that this angle, these two angles, this statement says these two angles are the same. So let's call this is alpha, that's beta. So alpha is equal to beta. Well, if you try to prove it directly, well, you can, it can be proved, but anyway, we need this all the time. So we will need to show that alpha is equal to beta. For this, if you look at this, for this, what do we do? So let's take, for this for the proof, let's say center is here. Suppose this is the center. Suppose that's the center. Maybe I can use different colors. Okay, here is different color. And let's draw this arc. This angle. Let's say this is that angle. This angle is, let's say, x. X is, on the one hand, it is 2 times alpha, and on the other hand, x is equal to 2 times beta by the previous theorem. So therefore, alpha is equal to beta, which is x over 2. Okay. Next, these are something probably you know well, but this is the simple proofs. So here's the theorem. This is so we are, for now, we are dealing with only the geometry in the plane, nothing else. It will be plane. So if I say, for example, if I say that, you know, if you take any 3 points in the plane which are not on the same line, there is a unique circle passing through all these 3 points. How do you prove this? Do you have an idea? An idea? Anybody have an idea? Hala giremeyen var mı derse? Artık giremeyen varsa da değiştiremem. Yapacak bir şey yok. Erken gelsinler. Var mı? Do you have an idea about this proof? So any 3 points in the plane which are not collinear determines a circle. Okay, so we need this. You need to think about this a little. Anyway, here's the proof. So the statement is that given 3 points, so if you try to let me first state this. Given 3 points, 3 points not lying on a line, in the plane, there's a unique circle. Unique circle passing through them. So, well, first I thought I can do it like this. So, proof. Well, you may try. So before this proof, you may try this. Well, that's what first I thought this way. So, and the equation of a plane, and so given a point x1, x2, x3, let's say, suppose we are given the point x1, y1, x2, y2, and x3, y3. Then equation of a circle is x minus a squared plus y minus b squared is equal to, squared is equal to r squared. Right? Like this. So the question is, so you need to determine this a, b, and r. For example, xi minus a squared, x1. So x1, y1, x2, y2 are known, and xi squared, xi, oops, not squared, b squared is equal to r squared. So you have 3 equations for I is equal to 1, for I is equal to 2, I is equal to 2, 3 equations, and many unknowns. Unknowns are 3 unknowns, A, B, C, but they are quadratic. How do you solve this? How do you solve this? I don't know. But instead, let me, how do we video? Anyway, instead, what do we do? Instead of doing this, let's go this way. So let's take the point A, B, and C, like this, which are not on the plane, so that you can, they determine a triangle like this. Okay. Let's take the midpoints of BC and AC. Let's say, I guess we'll call this later A prime, B prime. So A prime is the midpoint of BC, and B prime is the midpoint of AC. And let's draw these lines perpendicular to these A prime and B prime. So let's draw these perpendicular lines. Maybe I should, let me put here. So let's draw this perpendicular line, something like this, and another perpendicular line from here. Okay, let's look at the intersection point. Let's call that point is O. And if we look at these triangles, consider the triangle OBC and OAC triangle. So each of them, so this is OAC and OBC are isosceles triangles, namely, so this side is equal to that side, that's equal to also this side, so they are all the same, so that so this point O is uniquely determined by ABC. So O and let's call this R, that distance R, O and R are uniquely determined. Determined by ABC. So therefore, there is a unique, so if you look at the circle passing through this point, O, so with center O and the radius R, that it will pass through these 3 points. Okay, draw something like this. So there's the unique circle. There is the unique circle. Circle containing of radius containing ABC with center O and radius R. Okay, so these 3 points determines a circle. Okay. Next, one more thing that we will frequently see in this lectures. That is, okay. So that's this theorem. Oh, before this theorem, let me say definition. Definition: given a triangle ABC, triangle. Let's try, triangle like this. The center O in the above picture, like this here, the center O of the circle passing through ABC is called the circumcenter. The circumcenter. circumcenter of ABC. And its radius is the circumradius. So namely, so what do we have? So when we have when we have a triangle A, B, sorry, this is C, that's B. When you draw this triangle, and when you draw the circle containing ABC, the center of this circle is the circumcenter of the triangle, and its radius R, whose distance to all these three sides are the same. This is it's called the circumradius of the triangle. Okay. One more thing that as a preliminaries, I have one more thing. Suppose we are given a triangle. Two more things. When we have a triangle like this, A, B, C, we will always denote this side by A, that side by the length B, and this length will be C. So A is, we will write like this, BC, and B is equal to AC, and C is equal to AB. We will write either way, like this. Okay, one more thing is that, so suppose we have a circle and a quadrilateral like this. So namely, this is P, Q, R, S. So let P, Q, R, S be an inscribed equal quadrilateral. Then if you look at the angles, then the angle Q plus S is 180 degrees, and R plus P plus R is 180 degrees. I didn't know this before. So how do you show this? The proof follows like this. Why is that? So if you look at the center like this, then so let me draw this with different colors. So that this side is, so if you look at this arc, it is subtended by the angle Q and also this side. So it is 2 times Q here, 2 times Q. And this is, and that angle is 2 times S. That angle is 2 times S. Because